Hey guys, so this is the next part of our 13.1 through 13.2 series of videos, and this is about solving right triangles. You're going to look at, we're going to be looking for a specific side to a right triangle. If we look at the questions that we're going to be studying, we're going to be doing 6 through 10 in this section. And so we look at these and we have triangles set up where we have, um, an angle, one side, and a missing side. And so when we come back in here and we take a look at a right triangle, let's just say we had a right triangle like this. Let's put our finger here. Let's say that we don't know that side, but we have 13 for that side, and we're going to say our theta is 30 degrees. Okay. Um, so what we're going to do here, I'm probably writing a little bit small again, but that's a 32 right there. Okay. Let me just write it a little bit bigger. It's a little bit easier to see. Okay. So what we're going to do first is we're going to acknowledge which sides of the triangle we're talking about. This angle theta right here is our reference point, and this would be the opposite side. This would be the adjacent side, and of course, 13 is our hypotenuse. We know it's the hypotenuse because it's across the uh, from the near or from the 90-degree angle. Now that we have these labels, we're looking to figure out what sides of the triangle do we want to work with. We always want to work with the number that we have, and since we have the hypotenuse as 13, we want to use a trig function that uses the hypotenuse. So sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse, would both work really well. Tangent doesn't use hypotenuse, so I would reject it. Now, in terms of which one of these do I want to use, the question is, what do I want to know? Well, the missing side that I'm being asked to solve for here, x, is the adjacent side. So now when I look at sine and cosine, I want to pick the one that has the adjacent side. Well, that would be cosine. This tells me for this problem, I'm going to start by doing cosine of my angle 32 degrees, which is equal to the adjacent, I'll call that x, over the hypotenuse 13. Now when I solve this, I'm going to do it by timesing the 13 over. And now my x is alone. Now here's where we run into a little bit of a problem. Depending on what you have at home, maybe you have a scientific calculator that will do trigonometry, maybe you don't. I'm going to show you how to use Desmos so that if you do have a problem, there's an easy, simple way to fix it. So we're going to jump over here to the internet, and we're going to go to our favorite graphing calculator option, which is the Desmos graphing calculator. You don't actually need the graphing calculator component, but it's what I always use, so I'll just come here. What I needed was 13 times the cosine of 32. Now, I do need to be careful and make sure that it's in the correct mode. So I'm going to come over here to my graph settings, and I'm going to look and notice it's in radians. We don't want it in radians, we want it in degrees. That is going to make a big difference in the answers that you get. So for this problem, the answer for x is 11.02. Let's come back over to our problem. Oops. There we go. So x would be 11.02. As a side note, we could find this other angle, and then we could find this other side. That's something that we're going to do in our next assignment. For today, we're just going to focus on just finding one piece of information. Okay, let's look at one more example. Another another problem very similar in our right triangle trigonometry. This time, let's put theta up here. Call theta, let's say 20. Well, we'll go bigger. Let's make this degrees. 65 degrees for our angle. Let's do opposite side is 14. And I'm looking for this side here. Okay. So from our theta position, the opposite side would be the 14. Of course, we know the hypotenuse across from the right angle, and that would leave me with an unknown adjacent side. So I know that I have the opposite. So that puts me using either sine, which uses opposite over hypotenuse, or tangent, which is opposite over adjacent. But I'm looking to find the adjacent, which means the hypotenuse is not the right choice. I want to not use sine, I want to use tangent. So when I set this up, we'll have the tangent, right, of theta, which is 5, will equal the opposite side, 14, over the adjacent x. Now, when x is in the denominator, this problem's going to solve a little differently. I can't just times x over, because then I still have to move the tangent back. And so we talked about this in class a couple weeks ago, but if we take the whole tangent of 65 and the whole x, and we trade them places, Welch calls it the Welcheroo. You don't have to technically call it that, but switch or a swap that we're going to make with the denominator of the fraction and what the fraction is. X 14 over tangent 5. Now we can go to the calculator as our actual solution for that. And the nice thing about Desmos is that when you open it up, I'm not going to have to change the mode again. This is something where now the mode is set to be in the correct mode here. So we're going to do 14 divided by, and I love that it gives me the fraction. I like that. So then tangent, start of parentheses, 65, and close my parentheses. And I get 6.53. Let's go with that. So over here, we'd say that our x is 6.53. And that's it. Each of the problems that you're going to do, again, one small thing at a time. You're just going through and building the correct trig ratio. It's either sine, cosine, or tangent. And then you're going to solve that equation for either the top or the bottom of the fraction. It should give you an example of each. Good luck, and we'll talk to you during live chats.